Good evening, everyone. Today I will be demonstrating Bolin's law using marshmallow and a syringe and explaining how Bolin's law relates to the ideal gas law. Bolin's law states that for a fixed amount of gas at a constant temperature, the pressure and volume of a gas are inversely proportional. This means that when pressure increases, volume decreases, and when pressure decreases, volume increases. The mathematical equation for Bolin's law is P1 times V1 equals P2 times V2. A simple way to understand this is to imagine gas particles moving around inside a container. If a container becomes smaller, the particles have less space to move, so they collide with the walls more often, creating higher pressure. To demonstrate this, I have placed a marshmallow inside a syringe and sealed the end with my finger. When I pull back the syringe, the volume inside the syringe increases. According to Bolin's law, increasing the volume decreases the pressure. The air trapped inside the marshmallow expands because the pressure surrounding it is lower, causing the marshmallow to grow larger. As you can see, the marshmallow expands. Now, I will let go of the tip of the syringe. The volume decreases. This increases the pressure inside the syringe. The gas trapped inside the marshmallow is compressed, causing the marshmallow to shrink. This demonstrates the inverse relationship between pressure and volume described by Bolin's law. Bolin's law is one of the several gas laws that contribute to the development of ideal gas law. The ideal gas law is PV equals nRT. In the equation, P represents pressure, V represents volume, N represents the number of moles of gas, R is the gas constant, and T represents temperature. We can derive Bolin's law from the ideal gas law by keeping the amount of gas, N, and the temperature, T, constant, since nRT remains constant. The equation becomes PV constant, or the equation for Bolin's law. The other gas laws are also contained within the ideal gas laws. Child's law shows the volume is directly proportional to temperature when pressure is constant. Gay-Lussac's law shows the pressure is directly proportional to temperature when volume is constant. Avogadro's law shows that volume is directly proportional to a number of gas particles when temperature and pressure are constant. The ideal gas law combines all these relationships into a single equation that can describe the behavior of gases under different conditions. In conclusion, my marshmallow and syringe model demonstrates Bolin's law because changing volume changes the pressure acting on the gas. This relationship is one of the parts of the larger ideal gas law, which combines Bolin's law with the other gas law to explain how gases behave. Thank you for listening.